today, this is a continuation of the arithmetic progression problem, and we have this sample problem. This is our sample problem. So first we have to understand as well as analyze what is this problem is all about. So allow me to read the problem. So Alfred set out at a speed of 6 kilometers per hour from a certain point. Okay, after Alfred after Alfred had traveled for 2 hours, Benny set out to overtake him and went 4 kilometers the first hour, 5 kilometers the second hour, and 6 kilometers the third hour, and so on, and gaining 1 kilometer per hour. So the question here is that after how many hours were they together? So let's just imagine that we have two cars. Okay, we have car A, and this one is for Alfred, and car B, car B is for Benny. Now, what's happening here is that at starting point, Alfred set out and moved with a constant rate of 6 kilometers per hour. So after 2 hours, let's say that this is the total distance that Alfred traveled. Okay, let's assume that this is the total distance, let's say dA1. Now, after 2 hours, let me just delete this one. Let me emphasize that uh, after 2 hours, so after 2 hours, what happened was that Benny tried to overtake um, Alfred. Car B starts to move, okay, to overtake car A. Now, the condition here for car B uh, is that it moves with an increasing velocity or increasing speed of 1 every 1 hour. So after 1 hour, after 2 hours, then car B starts to move. So in 1 hour, after every hour, car B increases its speed by 1. What's happening for car B? Let me just change this one. So car B, car B. What's happening in car B is that there's this condition because car B wanted to overtake car A, or Benny wanted to overtake Alfred. What's gonna happen here is that after 2 hours, car B starts to move. So it moves here in this direction. Okay. Now the condition here is that every after 1 hour, every after 1 hour, the speed of car B increases by 1. So let's say that during the first hour, during the first hour, its speed is actually 4 kilometers per hour. And with that, there will be a corresponding distance traveled by car B. Let's say this is distance B1. Now, after 2 hours, same. So its speed after 1 hour, its speed increases by 1. So its speed now becomes 5 kilometers per hour. So this is for another 1 hour. And again, there will be a corresponding distance traveled by car B. So this is gonna be distance B2. And then let's say after an hour again, so its speed now becomes 6 kilometers per hour. So this is another 1 hour. And with that, there will be another corresponding distance that this car B traveled. So let's say this is distance B3. Okay. And let's say after another hour, it traveled again and its speed increases by 1. So this becomes 7 kilometers per hour, and there will be another corresponding distance that it will travel. So this is dB4, and this should be after 1 hour. Now, on the other hand, car A will just continuously move and so on and so forth along a straight line, okay, at a constant speed of 6 kilometers per hour. Now, um, we wanted to know here, our goal here, our goal is to find the time for car B to reach car A. Okay, how long will it take for car B to reach car A? So that's the goal here. So we wanted to know the time. Okay, now for us to know the time, let us have a quick understanding of the concept of speed. Um, Speed, symbolized by S, is distance divided by time. Okay. Now, in our condition, car B, car B wanted to overtake or to reach car A. So it means that we wanted to know we wanted to know the time, okay, the time total for car B to reach car A. With that said, you would notice that it means that the distance traveled of the two cars must be the same. So we want to say that the total distance traveled by each car must be the same, so that we could say that car B reached car A. So we would say this is the total. So with this condition, we could say that um, the distance total traveled by car A must be equal to the distance total covered by car B. So this is our condition so that we could say that car B reach car A. Okay. Now, going back here, we want to know how much distance traveled by car A. So, how much distance would you think covered by car A? Let's do that one. Let me use another color. Mm, about blue. Okay. So, to know the distance traveled by car A, we could say that, let's say, put here distance. We focus on the idea of distance. The distance traveled by car A can be calculated using this equation, the concept of speed. So derive the distance. So distance is actually the product of the speed times the time. So to solve for the distance traveled by car A is gonna be distance traveled by A is total. Okay, let me put that right, or let me put that correctly. So the distance traveled by car A must be its speed. So the speed of A times T, T total, I would say T total plus. Why is it that there is plus? Because our problem said that car A traveled earlier to ours. So car A traveled earlier than car B. So it traveled 2 hours earlier compared to car B. So we have to include this one, this distance, to our total distance. Well, this part here until here is the D uh, total, D total. No. This one is the distance that can be calculated. Okay, that can be calculated using this equation, the speed of A times the T total. So in short, for car A, there are two distance here. So for car A, we have the total distance covered by car A is D1, DA1 plus DA2. Our DA1 is the distance traveled in 2 hours. So that's gonna be speed of car A times speed of car A times the time, which is 2 hours. While for this one, we have to put that one the speed of car A times the time, and we don't know that time. So we have to return to our equation earlier. So going back here, so we know that we have to include as well the distance traveled by car A in 2 hours. So this is gonna be speed of car A times 2. So this is for car A. And this is the total distance traveled by car A. So the constraint here is we don't know yet this total time. Now for car B, this is a little tricky. Um, it started with its speed started with speed of car B start at 4 kilometers per hour, and then it increases by 1 after 1 hour, so this becomes 5 kilometers per hour, and then let's say 6 kilometers per hour. So each time the car B increases its speed, it travels different distances. So we have to individually add the distance traveled by each of these speeds. So going back here, just like what I've showed you earlier, So for 4 kilometers per hour, it traveled different speed, different distance. So we have to get that one. Same here for 5 kilometers, we have to add this distance traveled here by this, and so on and so forth. Okay, so we will going to make an equation to do that one, or to represent this one in an equation. We could say that the distance traveled by total by car B should be the distance B1 plus distance B2. We're gonna assume as well that the car is traveling at a straight line, plus distance B3, and so on and so forth, because we don't know actually how long will it take for car B to reach or overtake um, car A. Now, let us continue. For DB1, solving for the distance, we could use this equation earlier, the concept of speed. So we could say the speed, so this becomes speed of car B1 times time here is just constant, time 1 after 1 hour, plus again speed of car B2 times T1 plus speed of car B3 with speed after 3 hours times T1, okay, and so on and so forth. This continues, and we don't know yet how many terms we have to add, because we don't know the total time. But there is a pattern. We could simplify this further. So this becomes SB1 plus SB2 plus SB3. Let's start here. Okay. And then we're going to factor out the time. The time here is just simply 1. Okay. Now, since T1 here is just 1 hour, so we could just further simplify this equation to SB1 plus SB2 plus SB3, because T1 here is just 1. Now, we know that this one is actually 4, well, this one is actually 5, well, this one is actually 6. Notice that the common difference here is actually positive 1. Okay, so it means that this one is actually an example of an arithmetic progression. Now, since this is an arithmetic progression and we wanted to add each term, we want to add 4, 5, and 6, we know that we could use this equation to solve or to do that. And in arithmetic progression, to get the sum of each term, we will going to use the sum is the number of terms divide by 2, then get the first term plus the last term. Okay, we don't know yet the last term. However, and since this is an arithmetic progression, the value of the term can be calculated using this equation, n minus 1 times d. So for L, this should be a1 plus n minus 1 times d. We could substitute this equation to here, so we get n over 2 a1 plus a1 plus n minus 1 times d. Okay, we're going to simplify this further. So this leads to n minus 2 2a1 plus n minus 1 times d. Now going back here, we know that the common difference is positive 1. Okay, this is the common difference, positive 1. So in short, we could say that the d total for Carby can be found using this equation. We could say that the number of terms, we don't know the total terms, and then 2, the a here is actually the first term. Now in our problem, the first term here is actually 4, so we could just simply substitute that one here. We have here 4. The number of terms we don't know yet. The common difference is just 1. So we have n over 2, 8 plus n minus 1, like this. And this will be our equation in solving for the total distance traveled by car B. So let me write everything. So our first equation for car A, this is our equation. Okay, so earlier I said that the condition for this problem is that the total distance traveled by car A must be equal to the total distance traveled by car B. So we're going to use this equation. Okay, we're gonna use this equation and just simply substitute how the equations that we derived earlier. So for d total A, we're gonna use this one. So we have speed of A times t total plus SA, or 2SA. Now, I think it would be wise to make space for everything. I would just simplify this further. So speed of A times t total plus 2SA equals, for car B, this is our equation for car B, this one. So we have to copy that. That's gonna be n over 2, 8 plus n minus 1. Now we'll just simply substitute here the speed of car A. Since the speed of car A is constant, that's gonna be 6 t total plus 2 times 6 is just 12. We'll just first forget about the units here. Anyway, everything is in the same, every data there, the same unit, so there's no need for us to worry about that for now. Let us continue. So copy the right side of the equation. It's going to be n over 2, 8 plus n minus 1. Okay, so we're going to put here, our t total here is actually equals to the number of terms, because each term corresponds the time. So the t total here is actually equals to the total number of terms. So we could say 6 n plus 12 equals n over 2, 8 plus n minus 1 squared. So this becomes 6n plus 12. On the right side, we're going to distribute this n over 2 to each term. So we have here, it's going to be 4n plus n squared over 2 minus n over 2. And then we're going to combine like terms. So we have here, let's combine this one. Um, so this is positive 12 equals to minus 6n plus 4n minus n over 2, separate that first, plus n squared over 2. Okay, let us continue. Okay, let's go here. So that's gonna be positive 12, negative 6 plus 4n, that's gonna be negative 2n minus n over okay, plus n squared over 2. Okay, continue. This is gonna be common difference. A common denominator here is gonna be 2. 2 divided by 1 is 2, and then times negative 2n, that's gonna be negative 4n. Here we get negative n, okay, plus n squared over 2. So plus 12 equals, that's gonna be negative 5n over 2 plus n squared over 2. So what we could do next here is actually multiply each term on the left and the right by 2. So this becomes 24 equals negative 5n plus n squared. Now, let me simplify this further. So this is n squared minus 5n minus 24 equals 0. Okay? Notice that this is actually a quadratic equation. Okay? So this can be calculated using a quadratic equation. So that said, to solve for the value of n, what we could do now, you could use the quadratic equation, or I could just simply use factorization to do this one. So we're gonna look for two numbers where once we multiply, we get a value of negative 24, and once we add, we get a value of negative 5. Uh, for we know that 8, negative 8 times positive 3 gives us negative 24, while negative 8 plus positive 3, okay, this gives us negative 5. So the factor of this is actually n negative 8 and n positive 3. You could check this one and it should return to this one. So in short, this n minus 8 and n plus 3 is actually equals to n squared minus 5n minus 24 equals 0. So we could somehow simplify this equation to n minus 8 n times n plus 3 equals 0. Now solve for n. So our first value here should be n minus 8 equals 0 divide n plus 3. We get n equals to positive 8. Another answer here is that, okay, this is our first answer. And let's check the other one. So n plus 3 equals to 0 divided by n minus 8. And we get negative 3. Now, at this part, we're going to decide correctly, okay, correctly, which of these two answers is correct. The first one, let's say the first or the second. Now, the correct answer here is the first one, this positive 8, because n here is actually the total time. And there is no time should be not equal to negative. Okay? So since this one is negative, therefore, this is not the correct answer because there's no negative for time. So we're gonna use the correct answer here is 8. So after 8 terms, so that's gonna be after 8 hours. Where is it? Going back here. So after 8 hours, 1, 2, 3, 4, 5, 6, 7, 8. So after 8 hours, um, car B will reach car A. Let's prove that one. Let's check if that is correct actually. Let's see. Um, so let's check. Let's prove that if that is correct. So our answer is the total time is 8. So for the total car A, that should be 6 times 2 plus 6 times 8. Okay, so this becomes 6 times 2 is 12 plus 48. That's gonna be, that's 10, that's 60 kilometers. So it traveled 60 kilometers. Okay, let me put this correctly. So it traveled 60 kilometers. Now for car B, well, we could use the idea of the arithmetic progression. So to get the sum of 8 terms, we're gonna use this one, n over 2, the first term, plus the last term, or I think I would just directly use the second equation. So this should be 2a1 plus n minus 1, and the common difference is just simply 1. So the total traveled by car B, and here is 8, that because n is here is just the total time. So 2, well, the first term, the car B started at the speed of 4, and then n here is just t, which is 8 minus 1, well, d here is just simply 1. So let's continue. So we have here copy 8 over 2, that's gonna be 8, and this one is gonna be, and this is actually just equals to 7. times 1 is just 7. Okay, so 8 over 2. 8 plus 7 is just 15. Yes, that's 15. 15. 15 times 8 divide by 2. That should give us a value of 60 kilometers. Okay, so in the perspective, or in cars B in cars B perspective, it could reach car A after 8 hours. Now in car A's perspective, a car B reach car A at 10 hours because it already started here 2 hours, so we have to include these 2 hours. So 8 plus 2 is gonna be 10, and that's arithmetic progression. And that this is how we use a good example of how to use arithmetic progression in solving physics concepts. And hopefully, though my solutions are messy, hopefully you understand the logic behind how we solve this problem.